Hello student, I am Professor Jayanta Chopde, working in Electronics and Telecommunication Department. Welcome to this lecture on the classification of the systems. Now in previous lecture, we studied the operation on the signal. Hello student, I am Professor Jayanta Chopde, working in Electronics and Telecommunication Department. Welcome to this lecture on classification of the system. In previous lecture, we have studied the mathematical operation on the signal. And that mathematical operations are amplitude scaling, time scaling, then time shifting, two signal, addition of the two signal, multiplication of the two signal, and the folding operation. Now in this lecture we are going to study the classification of the system, and in that the different types of the system, and that different types of the systems are continuous time, discrete time systems, static systems and dynamic systems, causal and non-causal systems, linear and non-linear systems, time variant and time invariant systems, and stable and unstable systems. Now in first lecture, we studied what is the signal and what is the system. And in that, I have given one example that is, I am speaking with you. This is the speech signal. And what is the signal? Signal is the function of one or more independent variable, typically carries some type of information. Now I am speaking with you through this mic. Now this mic means microphone. This microphone is a system, and the input for this microphone is the speech signal, and output of this microphone is the electrical signal. Means we can define the system as a physical device that performs an operation on an input signal and produces the new signal. Another signal is called as the system. Now the block diagram for the system is this is the input and this one is the output. Input is also called as the excitation or the input signal, and output is called as the response or the output signal. And the input and the output signal is written as yt, that equal to txt, where xt is the input signal and yt is the output signal, and this t is the transformation, that characteristic that system behaves. Now in case of the amplifier is a system. The amplitude is increase or decrease. Means here the T is amplification or the attenuation. Now different types of the system, and the first type is the continuous time and the discrete time system. Now what is the continuous time system? A continuous time system is a system which deal with the continuous time signals, is known as continuous time systems. Now we know that there are two types of signals, continuous time and the discrete time. Continuous time signal is occur at every instances of time, where the discrete time signal occur at the discrete instances of time. When the input signal is continuous, and the output is continuous, that system is called as the continuous time system. And the amplifier for the systems are, example for these systems are the amplifier, motors and the filters. And discrete time system deal with the discrete time signals. This is shown in this figure. This is discrete time signal, and the output is also discrete at discrete instances of time. And the example for the system is the digital computer, digital filter and the microprocessor, any digital system. Then the static system and the dynamic system. Static system is also called as the memoryless systems. The systems is also called as the memoryless system, because the output of the static system it depends on only the present instance, or the output at the present instance depend only on the present input. Means output it depend on only present input, and this system is called as the static system or memoryless system. And the example for the static systems are the relation between V and I resistance. According to the Ohm's law, we know that V equal to IR, means as this current is changing, the voltage will change if R is constant. Means the output is depend on this input is current. At that instant, if voltage is current is changed, output will change. Means output it depend only on the present input, and the system is the static system. Another example, logic gates and the combinational circuit. In case of the logic gate, if we consider the OR gate, the output it depend on only the present input, not previous value. Now if we take this example yt equal to 2xt, we will find out whether the system is static system or dynamic system. Now present value is at t equal to 0, substitute the t equal to 0 in this, then this is 2x0. Now if present value is 1, then the input value is also 1, means the output value is depend on this only the present input, and the system is static system. The second example is this. If we consider here 1, this present value is at t equal to 1, then this is n x of 1, means that it depend, again this here n is 1, that it depend on only the present input, and the system is static system. Then second one is the dynamic system. Dynamic system is also called as the system with the memory, because its output is depend on the past inputs and the past output. Means output is depend on the present as well as past. Hence this system is called as the dynamic system. Now here the example for the dynamic systems are the relation between the voltage and current in case of inductor. We know that in case of inductor, voltage V equal to L di by dt, means this is differentiation, and we know that what is the differentiation? Differentiation is nothing but the difference between the present value and the previous value, means this is depend on the previous value, means past input, and this system is called as the dynamic system. And the examples in case of the digital system, this is sequential circuits whose output is depend on this present input as well as previous input. Flip-flops and counters are the sequential circuit. Now here we have taken this one example, 2xt plus 3xt minus 3. Now find out whether the system is dynamic system or static system. Now the present value is at t equal to 0. Then the output is depend on the present value as well as the previous value, that is past value. Hence this system is called as the dynamic system. Is the past value x of minus 3. Because here we are taking this t equal to 0, 1, 2, this is minus 1, minus 2. These are for t equal to 0, these are the past value, and for t equal to 0, these are the future's value. Then the another example, this is differentiation, this yn, this equal to xn minus 1. Now for present value of 0, find out whether the output will depend on this only present value input or the past. If we substitute this is 0 minus 1 means this is x of minus 1. X of minus 1 means this is the past value. Means output it depends on this past input, hence the system is dynamic system. Another examples are these two examples. Then the causal system and the non-causal system. The principle of the causality states that the output of the system always succeeds input. Succeed input means the output comes out after the input. A system for which the principle of causality holds is defined as the causal system. Meaning, simple word, we can say that the output it depends on the present and the past input, then that system is called as the causal system. Output is not depend on the future input. It depends on only the present and the past input. This system is called as the causal system, and this principle is called as the causality principle. Now here this we have taken one example. Now here determine whether this given system is the causal system or the non-causal system. Now if we substitute here t equal to 1 in this equation, then we are getting this equation, and this t equal to 1 is the present value y of 1. Means at t equal to 1, the output is depend on this x1 means present value, and x of minus 2 means this is the past value. As output is depend on the present value and the past value, the system is the causal system. The another example in discrete time system is this one, that is x of n that equal to n xn plus xn minus 3. Now for n equal to 0 means this is the present value x of 0 that equal to n x of 0 plus x of minus 3, or n equal to 1, this is x of 1, n means 1 here, this is 0, this is x of 1 plus x of minus 2. Now for 1, this is the past value minus 2, and this is the present value, means output it depend on this present value and past value. Hence the given system is the causal system. Similarly, we will check whether this system is causal or not, or non-causal. This system is causal system. Then the non-causal system, a system in which the output precedes input. Means output comes first before the input is known as the causal system. In case of the causal system, the output is depend upon the future's input also. Means the system in which this output is depend on the future's value is called as the non-causal system. And the non-causal system are the unrealizable in the real time, as output comes first before the giving the input. Now for this equation is given, this equation is represent the system. Now we will find out whether this is the causal or non-causal system. Now here for the present value for t equal to 1, if we substitute t equal to 1 in this equation, we are getting this equation y of 1 is equal to x of 1 plus 3x of minus 2 plus 6x 4. Now here for the present value of the x, this is the past value, this is the present value, and this is the future's value. Means at t equal to 1 output, it depends on the t equal to 4, means for the future's value, and the system is the non-causal system. Now we will take this another example, this second example. Now determine or check whether the systems are causal or non-causal. All the systems are non-causal system. Here if we substitute t equal to 0, this is depend on this x of 3, means this is future's value. For this second example, yn this equal to x of 2n, and if you substitute here n equal to 1, then this is y1 that equal to x2, means 1 is present and this one is the future's value, and this given system is non-causal system. Now the last example, this yt that equal to minus infinity to 2t x tau d tau. Now here we will consider this integration x tau d tau that equal to z tau. Consider this. Means we are getting this z tau 2t minus infinity. Now for y of 1, means at t equal to 1, means for the present value t equal to 1, we will find out, substitute this limit z 2t upper limit minus this z of minus infinity. Now the minus infinity, this is past value, but if we substitute here this t equal to 1, we are getting this is z2 minus z minus infinity, means the output it depend on this future's value, and this system is the non-causal system. Then the linear and the non-linear system. The linear system is the system which obeys the superposition theorem or superposition principle. Now what is the superposition principle? Now here if we consider the two systems as x1, consider the two systems with the input as x1t and x2t, and the output as y1t and y2t. Means the input is given for the system is x1t, then the response for the system is y1t. Similarly, the input is given to the system is x2t, and the response is y2t. Then if we combine these two inputs, that time the overall system, the response of the overall system is equal to the response of individual system. What is the meaning of this? Means if we combine this x of t and here the x of t that equal to x1t plus x2t, and due to this combined input, the response should be is equal to response of individual system, means y1t plus y2t. If this principle is satisfied, then the system is the linear system, and if this is not satisfied, then this system is the non-linear system. Means the response, this t of this x1t plus x2t, combine these two signals, and here the a1 and a2 are the arbitrary constants, and that equal to the response of individual system due to the first input, and this is due to the second input y1t and y. And if this condition is not satisfied, that system is the non-linear system, means this is not equal to this. Now most of control system is devoted to the explore the linear system. Now check whether the system is linear system or non-linear. This is x squared t. Now due to the first input x1t, what is the response? This square of this means x1 square t. Now the second input is y2t. Second input is x2t. Now for the first input x1t, the response is y1t, and that response is x1 square t. Now take second input x2 t, find out this response, that is of this system due to the second input, and that equal to x2 square t. Now combine this x1 t plus x2 t. Now the x of t, that becomes x1 t plus x2 t. Now due to this x1 t plus x2 t, find out the response or the output of the system, and that equal to yt, and we will represent this is x1 t plus x2 t and square this. Means this is the square, and here again this a1t and a2t, these are the constant, and both sides means left hand side and the right hand side are not equal. This is square of this, means x square t plus 2x1 into x2t plus x2t square. As both left hand side and right hand side are not equal, the system is the non-linear system. Now check the following systems are the linear or the non-linear system. Now first yt, that equal to ext. This is the system represented by the mathematical equation. Now here we will consider these two signals x1t and x2t. Now due to the individual signal, we will find out first the response of the system. Means due to the first signal, that is y1t, what is the response is e raised to x1t. Due to the second signal y2t, that equal to e x2t. Now combine these two signals. Now x of t now becomes x1t plus x2t, and find out the response. Now response due to these two signals, that equal to e x1t. Now instead of xt, substitute x1t plus x2t plus x2t. Now using this linear or superposition principle, we know that this yt, that should be equal to y1t plus y2t. What is yt? Is e raised to x1t, overall response of the system due to this due to the signal x1t and x2t, and the output due to the individual is e raised to x1t plus e raised to x2t. Now whether both left hand side and the right hand side are same? No, because this is e raised to x plus y, that equal to e raised to x into e raised to y. Means this is e raised to x1t into e raised to x2t, and that equal to e raised to x1t plus e raised to x2t. As these both are not equal, this given system is non-linear system, as the left hand side is not equal to right hand side. Now the second example, txt. Second example, yt, that equal to t xt. Now find out the response due to the first input and the second input. x1t and x2t. These are the two inputs given to the system, and this response due to the first input is y1t, and due to the second input is y2t. Now first find out y1t that equal to t into x1t. Then y2t that equal to t into x2t. This is response due to the individual inputs. Now combine this, and after combining this we are getting this x of t is now x1t plus x2t, and due to that find out the response, and that response is y t and that equal to, or we will say this is y3t that equal to t. Now substitute, instead of x of t we will substitute x1t plus x2t, this equal to t x1t plus t x2t. This is the overall response, and the individual is this, means add this, as we know that the y1t plus y2t that should be equal to y3t using the superposition principle, and here the y3t y1t is t x1t plus t x2t, and that equal to t x1t plus t x2t. Now if we observe this equation, then in this equation left hand side that equal to right hand side. As both left hand side and the right hand sides are equal, both sides are equal, hence we can say that the given system is the linear system. Then these are another example, and the systems are the discrete time system. Check whether these following systems are linear or non-linear. Now first, this yn is equal to a xn plus b. Now two inputs are x1n and x2n, discrete inputs, and due to that the response obtained are y1n and the y2n respectively. Then due to the first we will find out y1n. What is y1n? y1n that equal to a x1n due to the x1 input plus b, and y2n that equal to a x2n plus b. Means here we are replacing, in first to find out y1n we are replacing x of n that equal to x1n, and to find out this y2n we are replacing x of n by x2n. Then the combined response, that is y3n that equal to, due to this response due to this x1n plus x2n, respond due to this. Means to find out this y3n we will replace this x of n by x1t plus x2t. Means this is a x1n plus x2n plus b, and that equal to a x1n plus a x2n plus b. Now using this superposition principle to check whether the system is linear or not linear, we will verify whether this left hand side and the right hand side, both these sides are equal. That is y3n that equal to y1n plus y2n, the response due to the individual inputs, and overall response due to this combined input x1n plus x2n. Now y3n is a x1n plus a x2n plus b, and here y1n is a x1n plus b plus a x2n plus b. Means this becomes a x1n plus a x2n plus 2b, and here in this left hand side this is b. Means both sides are not equal, hence the given system is both sides are not equal, and the given system is the non-linear system. Then the next example is yn equal to n x of n. Now due to the first input, what is y1n, that equal to n x1n. Replace this x of n by x1n. For due to the second input, response or the output of the system is n x2n. Now combine this x1n plus x2n, find out the response due to this, and that is y3n, that equal to n x1n plus x2n. Now replace this x of n by x1n plus x2n, and that comes out n x1n plus n x2n. Now verify whether this given system is linear or non-linear. For that, the y3n that should be equal to y1n plus y2n. Now the y3n is n x1n plus n x2n, that equal to n x1n plus, add these two, n x2n. Now left hand side and the right hand side, both sides are equal, hence the given system is the linear system. Then the next system is the time variant and the time invariant system. A system is called as a time variant system if its response varies with time, and if the system response to an input signal does not change with the time, such a system is termed as called as a time invariant system. Means for the time variant system, response varies with time, while in case of time invariant system, response does not change with time. Now suppose we applied a signal x of t to a system and obtained output, and if we delete this signal by the t unit, then the outputs also should be delayed by the t unit. A t0 unit, if this one is t0, then output should be delayed by this t0. If this is x of t, response is y of t. Now the condition for the time invariant system is, we have to check whether the response varies with time or not. Means whether the system is time invariant system or time variant system. First determine the output of the system for the delayed input, and we will represent this is by this y of t. Output or the response of the system for delayed input, and then delete the output itself. Then in second step delete the response by that second, that amount of the second. And for the time invariant system, the response for the delayed input, that should be equal to the delayed output itself. And if this both left hand side and right hand side both are same, then we will say this is the time invariant system. Otherwise the system is time variant system, this is not same. And this image shows this condition for the time invariant system in case of for the digital system. Here apply a delay to the input, recompute the response or the output, apply the same delay to the original output, by that the sequence is delayed, and compare these two steps, and if both two steps are equal, then the system is the time invariant system. The linear time invariant system, that systems are called as LT time invariant system, LTI system. And linear time variant means that system is linear, obey the superposition principle, as well as time variant system, then that system is called as the LTV system, linear time variant system. And the system which both linear and the time invariant system, then that is called as the LTI system. Now if the system is represented in terms of the differential equation, then by observing the coefficient, we will say whether the system is the time variant system or the time invariant system. Now system is said to be linear time invariant if all its coefficients are the constant. Means if we take the example, this 2d2yt of this differential equation, dt square plus 3dyt by dt plus 2yt, this is equal to x of t or 6 or 5x of t, any constant. Now here all the coefficients are the constant. Now this is general equation for the differential equation, where this a0, a1, an minus 1, an, and these are the coefficients. And if this coefficient of the differential equations are the constant, then that system is the linear time invariant system. But if the coefficient is a function of time, then that system is the time variant system. Like this. Now here if I take the same example, I will take the same example, this is 2, and if this is second coefficient, if this is 3t, dyt dt plus 2t square yt is equal to y. Now here these constants are the function of time, and if any one constant is a function of time, that system is the time variant system. Now here we have taken one example to check whether this given system is time invariant or the time variant system. Y of n that equal to x of minus n. This is this system represented by this equation. Then delete this sequence by this k and find out this, recompute this new response, means that becomes x minus n minus k. Means here we are replacing this n by n minus k. The second step is delayed. Second step is apply the same delay to the original output. Now this is the original output. Apply the same delay yn minus k. This is x minus n minus k. Means this minus plus this become minus, and this minus become plus. As both left hand side and the right hand side are not equal, the given system is the time variant system. Now solve this problem whether the following system are the time invariant or the time variant system. Now first one is yt equal to txt. Now first find output due to delayed input. That yt. Now delete this input. This is x of t minus t. This is first equation. Then find out the output is delayed. Now replace the t by t minus t here. That becomes yt minus t. That is t minus t. The response x of t minus t is equation 2. Then verify whether the equation 1 and the equation 2 is same. This is y t x of t minus t is not equal to t minus t x of t minus t. And this given system is time variant system. The second example, yt that equal to e raised to xt. Now first find out the output due to the delayed input, that is yt that equal to e x t minus t, and output is delayed, means yt minus t that equal to e x t minus t. Then this is equation 1, equation 2. Output due to the delayed input, equation 1, and equation 2 is output is delayed. And as equation 1 equal to equation 2 is e raised to x t minus t that equal to e raised to x t minus t. Both sides are same, left hand side and right hand side are equal, and the given system is the time invariant system. X t square. Now for this system, first find out y t output due to delayed input, and that equal to x this t square minus t. Delete this input. This is the input, and if we delete this input, that become x t square minus t. Then delay output, that is y t minus t. Now here replace this t by t minus t, and that is x t minus t whole square. Then verify both are same or not. And that equal to x t square minus t as left hand side is not equal to right hand side. Given system is time variant system. Now take this example first. Y of n that equal to x square n minus 1. Now delete this sequence. Due to this delete input, the y n k that equal to x square n minus 1 minus k by k unit. Then output is delayed n minus k. Now substitute en by n minus k, and that is x square n minus k minus 1. Now verify the equation 1 and 2 are same or not. As the left hand side and the right hand side are equal, if this is x square n minus 1 minus k, that equal to x square n minus k minus 1, then the given system is time invariant. Similarly, you can find out for this system, second system, yn that equal to x2n. Now first find out, delete the input 2n minus k. Subtract. Then output is delayed, the y n minus k. Now substitute, replace n by n minus k, and that equal to x 2n minus k, and that equal to x 2n minus 2k. Now verify whether the equation 1 and equation 2 are same. Now left hand side and the right hand side is not equal, and the given system is time variant system. And the last example is yn that equal to n x y. Now first find out the output due to the delayed input yn k is equal to n x n minus k. Then find out this or delete the output response, that is yn minus k. Now replace this n by n minus k, that is n minus k x n minus k. And from this equation 1 and 2 you can observe that these equations are not same, hence the given system is not equal to yn minus k. And the given system is the time variant system. Its response is change as the time will change. Then the last type of the system, the stable system and the unstable system. The system is said to be stable only when the bounded output is bounded for the bounded input. Means input is bounded for the bounded input. If the input is bounded, then the output is bounded. That system is called as the stable system. But if the system for the bounded input, if the output is unbounded, this is at t equal to infinity, that become infinity, this system is called as the unstable system. A stability is an important parameter which determines the applicability, means whether the system is used in practice or not. For the bounded signal means finite amplitude, and this unbounded means infinite order. This is continuously increasing, and at t equal to infinity, that becomes infinity. Means for this stable system, the response should be absolutely integrable. Means minus infinity to plus infinity xt dt, this should be less than infinity. That should be finite. And second, as limit t tends to infinity in time domain, we will define this stability of the system as limit t tends to infinity, this x of t, the response y of t, that should be approaches to 0. If you observe these two, this is yt, this is xt, yt equal to this is less than infinity, this is absolutely integrable. And second, as t tends to infinity, this is decreasing, and at t tends to infinity, this becomes 0. But for the second, this is system input, bounded input, and output is unbounded. At t tends to infinity, this becomes infinity. It is not approaches to 0, and the system is unstable system. Now determine whether this system is stable or unstable. This equation is given, that is yt equal to x square t, and this signal is unit step signal. This one is unit step signal, means it becomes 1 square for t is greater than or equal to 0. 1 square is 1, means this is bounded, and this given system is stable system. The second one is yt equal to integration of xt, and this signal is unit step signal. It's integration of 1 dt and integration is t, and if we plot this nature of this signal, this is the ramp signal having the slope 1, and at t equal to infinity this signal is continuously increasing as t increases, and at t equal to infinity that signal becomes infinity, and the second system is the unstable system. This second system is unstable system. Now these are the assignment question. Check whether the following systems are continuous, static, causal, linear or not, time variant or not. Now in this lecture we have studied the different types of the system, and in that continuous time, discrete time system, then the static system and the dynamic system, causal, non-causal system, time invariant system and the time variant system, and linear system and the non-linear system. And most of systems are the LTI system, that is linear time invariant system, in the system which obeys the linearity principle as well as time invariant principle. That system are called as the time invariant system. Okay, thank you. We stop here.